Here's an example of an OR inequality, compound inequality. We're asked to find a solution to x less than or equal to 1 or x greater than or equal to 3. OR is symbolized with the symbol U in mathematics, which means union. So OR, union, means the same thing. So we're asked to find all the numbers less than or equal to 1 or greater than or equal to 3. That would be the solution to this compound inequality. You can't have both. You can't be less than or equal to 1 and greater than or equal to 3. You think about that. How could you be less than 1 and greater than or equal to 3? But you can have one or the other. So let's draw this on our graph. If x less than or equal to 1, we put a bracket at 1. And shade like that. And x greater than or equal to 3, we put a bracket at 3 facing up. And shade like that. And there's a graph of our solution. Now, how do we write this in interval notation? Well, we're looking at all the sets of all the numbers less than or equal to 1. So that would be from negative infinity, all those numbers down that side, all the way up to negative 1, including negative 1. Union, or going from 3 all the way up. How far do we go? Well, it goes infinitely up, comma, infinity. So all the numbers from negative infinity to negative 1, including negative 1, union all the numbers from 3, including 3, to infinity. This is the interval notation way of writing the solution. Now we can also write it in one other way. This is a new type of notation, which is sort of set notation. We would use a brace and say the set of x's with a line that means such that. Such that. And you'll see this in higher math books, that line, such that x is less than or equal to 1, or x is greater than or equal to 3. So we can write this set in this way as well. Now here's a problem we're asked to find or actually graph the solution to. In fact, all the time we've been actually graphing the solutions to these compound inequalities. So we're asked to graph the solution to this inequality, negative 2x minus 5 is less than negative 3, or, union, or, same thing, 6x less than 0. So, as before, we have to solve for x, and here we would add 5 to both sides. If I add 5 to negative 3, I get 2. So negative 2x is less than 2. And I divide by negative 2. When I divide an inequality by a negative number, what happens? It flips to the other one. So we'll have x is greater than, and 2 divided by negative 2 is negative 1. So x is greater than negative 1. And on this side here, I'll just divide by 6. So I'll get x less than 0. Divide both sides by 6. 0 divided by 6 is 0. So we have x greater than negative 1, union x less than 0. And let's graph this now. So x greater than negative 1 would look like this here. From negative 1, parentheses, everything to the right of negative 1 shaded. And then x less than 0 would look like this here, with a parentheses of 0 and everything to the left shaded. And we're looking for the union of these two sets. Union means all. And so we want everything on this set or everything on in this set. And actually that includes everything then. This or this. Remember, we're not looking at and where they overlap. We're looking at this or this. So this or this actually is the entire number line that is shaded red here. So our answer would be all real numbers. So our solution to this compound inequality is all real numbers. How do we write this in interval notation? Well, we're looking at all the numbers from negative infinity, all the numbers from negative infinity, all the way up to positive infinity. And so interval notation for all real numbers is parentheses, negative infinity, comma, infinity, close parentheses. And so this is the solution to this compound inequality with all.